All right, for time's sake, I'm going to pause you. And if you're watching by video, you can simply pause the video. But all right, so hopefully you're thinking y equals mx plus b. That's what you're after because you want slope-intercept form the graph. Last chapter, right? The first one is pretty simple. Add a negative 4x to both sides. That'll move the 4x to the other side. You get y equals negative 4x plus 9. Graph your y-intercept first. Ooh, a 9. Yuck. Okay, that should give me enough. So I'm at 9. From the y-intercept, use your slope down 4 to the right 1. 1, 2, 3, 4, 1. And I like to do a bunch. 1, 2, 3, 4, 1. Although I think I already see the answer. All right, second one. All right, easy. Add a positive x to both sides. Graph the y-intercept first, 0, 4. Slope is 1 over 1, up 1 to the right 1. All right, there's our point of intersection right there. Make sure you're stating the solution as an x-coordinate of 1 and a y-coordinate of 5. So x equal 1 and y equal 5, it's the point 1, 5. How many had that correct? Whoa, way not enough on that easy of a problem. The reason that was so easy was it was very easy to put both of those in the slope-intercept form. This is all stuff we've done already. Again, math builds. We learned how to graph using slope-intercept form. We can't forget it. We can't forget it. Okay. By the way, how could you test if your answer is correct? If you had time, you could put the 1 in for x and 5 in for y in the blue one, see if it gives you a true solution. If it's equal, you can put the 1 in for x, 1 in for y in the black one. See if it also gives you a true solution, correct? Remember that? Don't forget that. All right, so be careful. Hey, I just want to show you something real quick. Everybody look up here. I just want to review something quickly. Let's suppose instead this was a 3. Don't change yours, just watch. Let's suppose that would have been a 3 instead. This would have been a 3 here, correct? And then we would have divided both things by 3 and gotten y equals negative 4/3 x plus 3. And then our y-intercept would have been 3, down 4 to the right 3, right? If that would have been the original. Okay, I want you to tell me in words what kind of solution this is on the count of 3. Give you a second to think. What kind of solution is this in words on the count of 3? Ready? Here we go. 1, 2, 3. Consistent and independent. Awesome. Let's suppose you were graphing. Let's suppose you were solving and you got the blue equation was the first one and the second equation were the green one. What would you say the solution is? It is no solution, right? It's a null set. They have no point of intersection because the lines are parallel. What type of words do you use to say the solution on 3? 1, 2, 3. Inconsistent. Let's suppose one of the equations was the black one. The second equation was the purple one. One of the equations was the black. The second was the purple. First off, in words, how would you say the solution? Here we go on 3. 1, 2, 3. Consistent because there's a solution. Dependent because there's an infinite number of solutions. Somebody tell me in words the concept of what are the values of the solution? Can anybody answer that question? I don't mean the actual numbers. I mean the concept. What is the solution to this one with the black and the purple? Kirsten? What point of intersection? And that's what I'm asking. What do you mean by that? Okay, why it said infinite points along the line, right? Isn't that the solution of the black and purple? It's every point along the line, right? Because don't they intersect at every point along the line? So it's the infinite number of points along the line. So how do you say that solution then? How do you write that solution? What would you write? So besides it being consistent and dependent, how do you write the solution? Ileana? So tell me how to write it. Tell me what to write. Tell me what to write. This is the black one and the purple one. That would be a correct solution. She chose that form of the black one. You could have also written the original form of the black one, which is in standard form. Okay? Written solution would be either the black one standard form or the black one slope-intercept form. I'll take it either way. They tell you which one you'd have to give it. Because remember, it's all the points along the line. That's how you give the solution to a consistent and dependent. All right. Solve this one by substitution. Solve this by substitution. 2x plus 4y equals 28. And the second equation, so 2x plus 4y equals 28. The second one, x minus 3y equals negative 21. X minus 3y equals negative 21. I'm going to pause. All right. Hey, guys, some of you wouldn't have had enough time to finish, and that's okay. Let's see if you were on the right track. All right. So just pause where you're at, and let's get advantage of the review. Told you to solve by substitution, so you have to say to yourself, do you want to solve the blue one for blue x or for blue y, the black one for black x or for black y? Your choice should have been to solve the black one for x. And then you simply add a positive 3y to both sides. I always circle that. I now want to substitute that value in for the x of the other equation. Negative 21 plus 3y. Now again, you can have 3y minus 21, same thing. Distribute. Negative 42 plus 6y plus 4y equals 28. Slow down. 6 and 4 is 10y. Add a positive 42 to both sides. That's a 70. Divide both sides by 10. And you get y equals 7. How many got y equals 7? Okay. And then remember, the easiest way is sub that into your circled equation to get that other value. So we're using a 7. Negative 21 and positive 21 is 0. Don't forget to write your final answer as a point of intersection, the point 07. Alexis. Speak up, I can't hear you with. You see it? Because I didn't hear your question at all. I need you to speak up because I can't hear you. Where did the negative, and that's all I heard. Okay, so right off the bat, Alexis, on our distributing, 2 times a negative 21 is a negative 42. Where did it go? I then added a positive 42 to both sides to isolate the variable. 28 and 42 gave me that 70. It's always easier when I can understand the questions. All right. Sound good? All right, and then the third method, you're not going to be able to finish this, but I'm just going to start you on it, see if you remember what to do. So solve this one by addition. Or, I'm sorry, elimination. Keep wanting to do the old style. Solve this one by elimination. Find a decent problem. Solve this one by elimination. Solve this one by elimination. 5r plus s equals 17. It's going to be a fairly easy one. 3r plus s Actually, I should do these this way. 3r plus s equals 12. All right, solve that by elimination. 5r plus s equals 17. 3r plus s equals 12. I'm pausing. All right, I know, again, you probably didn't have enough time, but let me just pause you. Hey, hopefully you decided to get rid of the s's. Multiply one of them, top or bottom, by -1. My new blue, -5r minus s equals -17. Be careful. Add them up. -2r equals -5. Divide by -2 and get r equals 5/2. Oh no, a fraction. Surely it can't be. Get it? Oh, it's a fraction. Big deal. It's the answer. Now, how are you going to get the s? I don't know. I'll use the black one. 3r plus s equals 12. Sub in the 5/2. Oh, now we're really in trouble. 15/2 plus s equals 12. Add a -15/2 to both sides. Oh no, common denominator. I'm quaking in my boots. 24/2 minus 15/2 is 9/2. Whoops, and that's not x, that's s. Put them in order. R comes before s. 5/2, 9/2. Anybody get it? Amazing. I know a lot of you didn't have enough time. All right, be ready. Quiz mañana, quiz mañana, quiz mañana.